We are recording.
Welcome to Practical Preamp course. This is January's edition. So the first one of the new year. Last month we talked about, we did the repair checklist. We talked about how in many industries in many industries I cannot speak this morning. Checklists are done to avoid error, remove human error out of the equation. And this week we're talking about the new amplifier startup. So after you build an amp, the first time you turn it on, what do we do? Got this special guest today, Adam Grimm from Satellite Amps.
Hi.
A little background on Adam. Adam has been, I'm sure he knows it, but whether he knows it or not, he's been like my mentor over the last several years. Every time I get stuck, I reach out to Adam, and he's been like my best amplifier buddy. So I really appreciate him, and I appreciate his advice, and he has very good practical advice, and that's why I invited him on. So, and he builds lots of amps. And so, Adam, how long has Satellite been around?
20 years almost. I think the first amp I built was the first amp I built as actually trying to be a company was, I think, late 2003. So 21 years. But we didn't really get started for about a year after that. I built a couple amplifiers in the late 90s, but that wasn't intending on being an actual amplifier company. That was for a band, and that's what got me hooked on building amplifiers.
And if you don't mind me asking, how many amplifiers do you build every year now?
That's a great question. Right now, a little over 100 a year.
And do you? I know you have some employees, but who does most of the wiring?
So right now, after COVID hit, I went back to just being by myself. Right now, there's two other guys that help me out. When we were running full bore and we had 5 employees, we were closer to about 300 amps a year. Realistically, in a manufacturing sense, if you're running your own business, 1 product a week is doable. 2 products a week is pushing it. 3 products is really struggling as one person.
Yeah. And
that goes for guitar making, amp making. Making a pedal is a whole different story. But when you're putting in something where you're the efforts of running the business and doing everything else into it takes a bit of time. The small end, the easiest amplifier we make takes me an hour and a half to build, start to finish, from a blank chassis to being done. Our most complicated takes about 8 hours of actual building.
What's your most complicated one?
The most complicated one is called the BL5000, and we don't make very many of them.
Is that the big bass amp?
No, it's a guitar amplifier, but it's got cascaded EF86s in the front end. There's a lot of fine tuning to make sure that it's not noisy. It's quite a lot of effort.
Gotcha. And could you build that one in a week, you think?
I mean, if I sit down right now and I pull a chassis out and nobody talks to me, I can build it in 6 to 8 hours.
Yeah, but that's not normally what happens. You got to do Zoom meetings and jump on email and stuff.
And I'm married and I have 3 kids, and I'm in, my shop is in the front corner of an actual working recording studio. So, I don't know who's going to knock on my door, at any time. Yeah, I locked the door. Just checking.
Yeah. So 100 amplifiers a year is a lot for a single operation.
It's doable. It also all depends on when people order the easy ones, I can burn them out really fast, and it comes in waves. Sometimes, gift giving time, pre-Christmas, we get people order the smaller, less expensive amplifiers to give us gifts. So those are the easier ones to build.
Right. Gotcha.
Tax day is when everybody gets their tax returns and orders the expensive ones. So, late April, early May is the long builds.
I just got a Word document up, basically, Adam. And once you have soldered the last thing, or what you think is the last thing, what's the first thing you do, like before you turn it on?
Okay, so for me, it's how I test things is going to be a little bit different than I would recommend a home builder do stuff.
That's all right. Talk about you. Talk about you, and then talk about how a home builder should do it.
That's exactly what we do. So for myself, and also when we've got employees doing stuff, we take a bare chassis, we put all the parts on, we wire it all up. Then before we plug anything in, put a fuse in or anything else, we double check everything, and we have a checklist. One guy uses a piece of paper and a highlighter, and he highlights every connection. I just mentally go over the stuff because I built this stuff, and in my head, I know where everything should be. So I just double check and make sure everything's soldered, make sure that there's no, we use turret boards, so it's very easy to wrap a wire and miss a solder joint. So double check everything. I use, we call them pokey sticks. It's basically just a wooden dowel that we have sharpened like a pencil. I've got, it's just literally just a wooden oak dowel. Go and poke every connection to make sure that they're all solid. Then I go put a fuse in it. I put tubes in it, and I go turn it on. I don't even hit the standby. I hit it full blast as hard as I can. The reason for that is that by the time I get to that point, if all of my checkpoints are fine, I want to know what a customer could possibly be doing in a worst case scenario when they get the amplifier.
Gotcha.
I don't recommend this to people doing this on their own. I also have, I can't really show it under my desk, and on my test rig over there in the other room, I have isolation transformers. So I've got protection set up so I can't electrocute myself. Everything is fused properly so that if something goes, it's going to pop that fuse immediately. If there's a component failure or something like that, we'll know immediately, and it's not going to cause that much damage. At that point, I plug a guitar in, honestly, and I hit a couple of chords and make sure that everything's working right. Then I'll flip the amp over and I'll start checking voltages. This is exactly the opposite of what I would tell somebody to do if they were doing this at home.
So, couple questions. So when you have employees building them, do you have written layouts, or you have written layouts for them to look at?
Yes.
Gotcha. How do you create?
We don't. I've never written a schematic for any of my amplifiers. There's only layouts.
Okay.
My first employee, Phil, he helped wire. Well, actually, technically, he was my fourth employee, but he was the first guy that was doing just hired purely for wiring and didn't really know. He didn't know color codes. He didn't know what values were, but he could solder two wires together. So everything was written as the actual color of the resistors. So it was brown, black, yellow. So it's 100K. So it was all written out as colors. So all of his bins were done in colors. So that's how he wired things. He didn't understand how anything worked at all.
That's awesome.
He didn't have to, it's, I'm assuming everybody knows some of this stuff. Resistors have a color code to them. So there is it's a weird kind of semi-reverse rainbow. And that color code tells people to understand what the values are. So when I say brown, black, yellow, brown is 1, black is 0. Yellow means that there's 4 zeros after that. So that means it's 100,000, which is 100K. So I'm assuming that Luke understands all of this. I don't know how many of your followers are following this. I want to make sure I'm not.
Some of us do. No, some of us. Yeah. Some of us do. Some of us don't. It's a good review.
And it's something that when I first started out, the guy that helped me learn how to do all of this gave me a box of resistors that were random and just had me sort them. So I had to learn the color code by sorting a box of stuff into the right bins of knowing it. And that's how I learned how to do it.
Yeah. I use a little app on my phone that tells me, but obviously the longer you do it, the stuff is intuitive. You know what color you know what the colors are just by looking at them. I lost my other question. So
the very first written layouts, I still have them somewhere. I should dig them out. I mean, it's like an MS Paint, horrible computer graphic. My graphic skills are not great for doing it. I mean, it's hilarious. Included all the colors of which color wire we wanted for different stuff. Because we have different colors. The wires were color coded so that filaments were a specific color, signal was a specific color, high voltage was a specific color. So we could also compartmentalize everything and figure out. He knew that the red parts were high voltage stuff. It also meant that anybody that was working on our amps that could follow along pretty quickly. If I said to check the B plus voltage, you could go down the line of the red wires and follow them.
How do you draw your layouts now?
I've just gotten better at doing graphics. It's just that the first time I did it, it was horrible.
Gotcha.
And you're talking about, 21 years ago. Not when I started doing this, I didn't know anything really about manufacturing. I didn't know how to do this for other people. I didn't know how to, I didn't even really know how to draw a schematic. It's been a lot of learning over 20 years to figure out how to do all this stuff. There's also a lot of programs now that didn't exist back then to help. I can go on my computer and pull up Eagle or something and draw up a schematic real quick in minutes.
Yeah. I use DIY Layout Creator.
Right. There's a ton of them out there that are all very good. It's whatever you're most comfortable with. To be honest, I've been using Eagle for so long. It's antiquated, and I would not specifically recommend it. But it's what I know.
And for clarification, most of your amps or all of your amps are just volume tone, right? You have a TMB model or anything?
I have. Yes, we've done a couple that are bass and treble. We will do a treble middle bass occasionally if somebody asks for it. We will do reverb and tremolo if people really, really need it. I don't. Part of when I first started building amplifiers, I realized a couple of things. One was that a lot of the amps I liked, which were old, and I'm talking like 1930s Gibsons, Rickenbacker, stuff like that, had either volume or volume and tone, and that was it. And they sounded phenomenal. One of my favorite amps of all time is the Gibson EH150 from the mid 1930s. It's just a phenomenal, it's sounding amplifier. The 185 is the Charlie Christian model. It's also phenomenal. I realized that my own playing style, I was a punk rock kid in Los Angeles. That's what we did. That's how I learned. That was the music I played. It ruined me for a variety of reasons in guitars and styles because of what I learned to like. My first guitar was a Squier Strat with humbuckers. To this day, I hate Strats with single coils. They sound wrong to me because I grew up listening to humbuckers in my Strat all the time, and that's what I think it should sound like.
Yeah.
I was playing a JCM 800, and I would just dime the thing straight across the top, everything on 10. That's what diming means for anybody that doesn't understand that. I didn't really touch my controls on the amplifier. I did everything on my guitar. So that kind of taught me that a lot of the tone controls for a good sounding amp weren't necessarily needed for everything.
Mm-hmm.
And this is like, I was 15 years old, 16 years old, and our guitar player got a Mesa Boogie amplifier. And he was so excited. He got it for Christmas or something. He brought in this thing with all these knobs and all these dials, and we played with it for about a half an hour before we could get it to sound good. It completely destroyed practice every time because we spent so much time dicking with this amplifier to get it to sound good. And I wanted an amplifier that you turn around, you turn it on, it sounds good. The end.
Yeah. I agree with that philosophy. I have I also have a bunch of Mesas and all those amps, but I've just finished up a volume tone gain amp, and it's just like when there's only 3 knobs to mess with. If you don't like the amp, turn it off and play something else. And
yeah,
it's awesome. It takes me.
I don't have the time to screw around with stuff where it takes me too long to enjoy what I have to do. I want to be able to get in, plug, enjoy it. And honestly, I build every single amp that we sell because I like it. I don't build them for other people.
Well, everybody else likes them too, because that's why people keep buying them, right?
Yep, I hope so. And to be honest, I've got a Mesa Boogie. I've got a couple of amplifiers that have a lot of knobs on them now. And I've got amps with single knob. I made one amplifier once for a guy years ago with no knobs on it. It's just a preset volume, and that's all you get. Because he controlled everything on his guitar, and he didn't want a sound person to ever tell him to have to do anything to his amplifier.
I love that. It's awesome. All right, so let's talk about checklist for somebody
Oh,
who's building something for the first time or maybe new to building?
so
How would you tell them?
when somebody comes to me and says, "Hey, I'm building a kit amp. I'm doing this. I want to learn or whatever," the startup process and what I recommend for them is a lot different than how I do things. Um, first thing is obviously, once you've built your amp and you think it's done, go and dump before you plug anything in. Don't put any tubes in it, no fuse, no anything. Don't plug it in the wall to see if the light works. Don't do anything. Go double check all of your connections. Don't use a pencil because lead conducts electricity. It's not lead, it's graphite, but it still conducts electricity. Don't use a pen. Use something that's wood or plastic only so you can't get shocked. Get used to doing this all the time. Never use a screwdriver. It hurts. I don't know if there's any amp tech out there that hasn't shocked themselves at least once or figured out why that's a bad idea. So go through, double check every single connection, print out your layout. I prefer layouts for people that are beginning than schematics. And most amplifiers, Fender's are great because he always did layouts for his employees. So you can find all of the Fender layouts for almost every single amp up until about, 1995. Find out where all the parts are. Go push on every single connection. Make sure that your solder is done. Everything is connected and solid. My startup procedure for actually when you actually are going to turn the amp on and put electricity on it. If you don't have an isolation transformer, you need or a variac or something, you at least need a current limiter. There's a variety of ways to do it. The light bulb in line with the electrical cord is probably the easiest way to do it. There's also something that I recommend people. Amp Saver. This is a Mercury Magnetics product. It is basically a current limiter and a voltage ramper, so it will slowly ramp up voltage to things. You guys want basically trying to make it so that you're not hitting your amplifier with full voltage when you turn the amplifier on. I've actually left out a step. After you check all of the connections, turn the amp upside down and shake the crap out of it and make sure there's no pieces of wire or solder stuck inside of it. I do that all the time in my builds and everything else. It's just a habit of just picking an amplifier up and shaking it just to make sure you don't have a piece of wire jumping something inside there.
Yeah. Blow it out with an air compressor.
Blow it out with an air compressor. A lot of people don't have air compressors in their shop, so that's why it wasn't. I'm trying to think of what people have at home. Variacs are nice because you can ramp up voltage slowly on a dial. A lot of people don't have them, and some people that have them don't know how to use them. You don't want to be turning on an amplifier with equipment you're not familiar with. I guess another one I would throw out there is if you have somebody else that has experience, have them help you. There's no shame in saying, "Hey, dude, I'm starting my amp up the first time. Can you make sure that I don't kill myself?"
Yeah.
Most of us are pretty kind, and we'll try and make sure that, like, if some customer wants to come over and fire up their amp here in my shop, I'm more than happy to let them come over, and I don't charge them anything. Just walk them through the process and make sure nobody dies.
Yeah, and to elaborate on the whole light bulb limiter, variac, isolation transformer, I've gone over this before in previous episodes, and I have lists. So if you need those lists, there should be on the Luth Group website. And if you can't find them, just text me and I'll send you over one. Yeah, light bulb limiter and or a current meter and a variac are kind of like minimum bench tools if you're doing this with any regularity. You don't need one if you're just building one kit. But like if this series is supposed to be for people that are trying to get into this to do with some regularity.
Isolation transformer. If you're going to try and do this with regularity, of all of those, isolation transformer is probably the biggest thing that very few people use. Isolation transformer, a transformer is two coils right next to each other. An isolation transformer basically makes it so that you're not connected directly to the wall, so that if you do electrocute yourself, you don't die.
Now, did you build one or did you buy one?
I actually just had an isolation transformer I already had. I bought it at a surplus store years ago. So it's a 20 amp isolation transformer that sits under my bench. And I've got a 10 amp over there where I test my amplifiers out.
I don't have an isolation transformer yet.
Well, you should get one. I don't want you to die. And you do enough stuff where when part of the reason for having an isolation transformer is when people bring in amplifiers that I'm unfamiliar with completely, that they've built themselves. If I'm going to be working on it, I have no idea what they've done. And getting shocked, I've been shocked a number of times with the capacitor. It hurts. That's enough to teach you that you don't want to be stuck to the wall. And 120, which is what we're using for all of our American amplifiers, it sticks you. So if you get stuck on something, it will keep you attached to that chassis. And most of us are working in our garages or in our basements or whatever by ourselves without somebody with a 2x4 to hit us off of it to save us. Of the other two things, the variac and the current limiter, people need to get used to a current limiter. That's really important. When an amplifier gets turned on, I know you've explained this, but there's what's called the inrush current. So that's what all the things that need power suck it all in really, really fast. If you have a direct short somewhere, you have a current limiter, it's going to stop that and slow it down so that you're not going to fry your transformers. A variac is great. I have one that I keep. I don't know if you see it right there. That's my variac I use all the time. It's just a great thing to be able to slowly up the voltages for stuff. That amp saver that Mercury makes, it is a little expensive. It's got settings on it so you can set the amount of current, the amount of time it takes to ramp the voltages up. So it does what the light bulb and a variac does on its own. And it's a microprocessor controlled timer inside. Takes all the guesswork out of all of this stuff. You plug it into the wall, you plug your amp into it. It does all of this without having to think twice about it. And they're on the Mercury Magnetics website. No, I don't work for them. I do like them. I don't get anything for doing this. It's a device I do recommend to a lot of people that are starting off with this because it will save a lot of their own troubles. Okay, back to the checklist of how we're going. So we're shaking the amplifier out. Made sure our light bulb is in there. If you have two fuses, one is your HT fuse and one is a mains fuse. An HT fuse is only to save your output transformer. It's not, you want to have whatever the properly fast blow, and that is usually it's like a 250 or 500 milliamp. If you don't have one and you only have a mains fuse, before you put any tubes in there, all right, Sorry, I'm seeing questions up and I'm seeing where to answer these at the end. All right. In your mains fuse, put in too small of a fuse. If you have an amplifier, if you're building a Tweed Deluxe that needs a 2 amp fuse, put like a 500 milliamp fuse in there. Put it in. Don't put any tubes on it. Plug it into whatever you're using to ramp your voltage and your current up, and turn the amp on. And start bringing it up. And just see if you're getting your indicator light to turn on. The reason for the smaller fuses is it will blow faster if you've got a direct short somewhere. And you're not drawing a whole lot of current if you don't have any tubes in your amplifier. So you can put in you need more than like a 10 milliamp, but you need 250 milliamp, 500 milliamp fuse. Assuming everything works right, then what I'll do is I'll take my meter out and I'll start checking voltages. Since there's no rectifier in it, or if you're using a solid state rectifier, you check your filaments, you check your high voltage going into whatever your rectifier is. So it's pins 4 and 6 on your rectifier tube, or if you've got diodes, it's on the beginning side of the diodes. And make sure you've got all of your voltages where you think they should be. Check them from ground to each point, and you want to check across your filaments. Turn the amp off.
All right, hold on. I'm writing some stuff down. So,
right.
So you're saying turn the amp on. Amp on.
Put too small of a mains fuse in.
Uh huh.
Turn the amp on. Make sure the light comes on. If the light doesn't come on, you have a problem. If it blows the fuse, you have a problem.
Yep.
Turn the amp off, unplug the amp, figure it out.
Gotcha. All right. All right. Let me put a note in here. Uh-oh. All right. Spell. All right. Let's see here. Back to all right, but all right. So if there's no short, then you're going to measure voltages, and
I'm going to measure my filament voltages. And so when you're doing filaments, there's two different kinds of ways that they're going to. There's a variety of ways of doing filaments. Most modern amplifiers either have two sides coming off of a transformer and either two resistors to ground to create a center tap, or there's a center tap off of the actual transformer. So that means that there's a ground connection. So you can check from ground to each side, and you want to check at the end of the line. So having filaments at the transformer side, you want to check all the way, usually it's the very first preamp tube is the end of the filament line. So you want to check there to make sure that you've got your filaments. So if it's 12X7, it's checking pins 4 and 5 and 9 to ground. You should have 6.3 volts, or you should have 3.5 volts on each side. But you're checking to make sure that whatever filament you're looking for is correct. You also check the filaments on your rectifier tube if you have them. So 2 and 7 should have AC 5 volts. Unless you're using like a 6CA4. Whatever. If you're using a weird random rectifier, you got to know what pins there. But check your filaments to make sure they're the right voltages before you put any tubes or anything else in.
Rectifier filaments 5 volts. All right.
Then you're going to check your B plus coming off your transformer. So it's not technically B plus yet. It's just the high voltage coming off. That means that your amplifier is on and your standby is in the playing position if you have a standby switch. And so you should be able to check ground to each side. They're usually red wires coming off the transformer. I think they're red.
Yep.
Yeah. Sorry, I'm having a little bit of brain fart. So you want to check from ground to that with a meter and make sure that you have high AC voltage. Should be, depending on the amplifier, anywhere from like 2 to, basically a couple hundred volts on your B plus.
Yep, and that's before it goes into any rectifier.
Before it goes into any rectifier or anything else, you want to check the voltage going into your rectifier. So if you got solid state rectifier or a tube rectifier, diodes are a tube rectifier is technically a diode. It's a 2-part tube. That's why it's a diode. So we use solid state diodes for stuff. They're the same thing. They're just two different ways of doing it. So you want to make sure that before the diodes, you've got your high voltage AC.
Yep, got it. I need to write in here no tubes somewhere.
Yes.
Turn on out tubes. All right, gotcha. All right.
So now we're going to move on to the next step, and this is where you have to start worrying about a little bit of things. So the next step is going to be, for safety's sake, unplug the amplifier, remove the fuse, put the proper value fuse in. At this point, you're also going to need to have a speaker or a load. If you don't know what a load is or have never used one, use a speaker to be safe. Preferably an old one that you don't care about, but that does work. Don't plug it into like your 1950s Jensen that you pulled out of your grandfather's Deluxe just to try out your amplifier the first time.
Yeah, I know a lot of guys just like using dummy loads all the time, and I like plugging into a speaker, so like I just know if something weird is going on immediately.
I'm the same way. I've got a couple of dummy loads. I don't think I've used a dummy load on one of my own builds in probably 10 years, maybe more. Yeah. I will use them for other occasions, but for the stuff I build, I don't use dummy loads. I use speakers.
Yeah, I mean, you can, if you have a scope and you know how to use a scope and you have a dummy load and you want to plug it in there for whatever reason, then more power to you. But I just like, I don't have to look at the amp and my hands and the screen. I can just, if something's wrong, I can hear it. I don't have to look at anything, and I can turn the amp off immediately. So that's why I like to use a speaker. And I think that's your same way for you.
You know, I have 2 benches. We're in my actual like build works for my own madhouse of stuff here. I have a scope over there on the other bench. I rarely turn it on. I mean, I never turn it on for my own builds. I don't have a reason to scope anything. Scopes are great for diagnostic tools and stuff. For amateur builders who are doing stuff at home, a lot of guys will buy scopes that don't know how to use them, will buy something they don't need or is more than they need. Scopes are pretty far down the list of things to me for people starting out doing this.
I agree.
Buy a scope when you find you need a scope.
Yeah.
Same with, I've got a couple of other, I have a couple of variable power supplies and things, so I can actually plug in supplies to adjust individual voltages in an amplifier. Again, it's not stuff that most people will ever need.
Yeah. Yep, I agree. All right, so we got our amp.
Okay.
We got the right fuse in there. We got the amp plugged into a load, and now what?
And then we're gonna put a rectifier tube in it. If you can, and this is something that because of what has happened over the last couple of years, it's great if you have a set of tubes that you already know work. Every once in a while, if you use a set of tubes that are brand new, you might get a rectifier that's bad. You might get a power tube that's bad, and it will make you think your amplifier isn't working properly. So if you can, either test your tubes in another amp beforehand, or try and use a set of known good tubes. If not, it's fine. Totally understand it. Put just the rectifier tube in it. Nothing else. Turn the amp on.
And if you don't have a tube rectifier and you have a solid state rectifier, you can mimic this by just flipping this. Then in the first part, leaving the standby off and then flipping the standby on.
So the reason for this is whether you've got once we put the tube rectifier in, or if you've got solid state diodes, you've already hit this point. But the tube rectifier is actually going to put a load on the film on the rectifier filaments. So it's actually going to start putting a load on the transformer, and that's what we're trying to do first. So we're taking this in stages to ramp up the amount of load we're putting on the transformer. When we talk about currents versus voltages and whatnot, we're talking about the current demand of the circuit and what is being pulled through the transformer for the transformer to get hot, to overheat, to find out if you got shorts anywhere. The more tubes you add, the more current the transformer needs to produce. So it's kind of this loop of trying to slowly make it get to maximum usage, if that makes sense.
Yep.
So at that point, tube rectifier in, or if you've got a solid state rectifier already in there, amp on. You still want your current limiter in case you just leave the current limiter attached, so that like don't bother worrying about like if everything's fine, it's perfect for being there. It's only going to be an issue if there's a problem with the amplifier. So turn it on, hit standby switch, so you're in play mode. So you're now give it 15 or 20 seconds. That's going to get the amplifier heated up, warmed up, and it's going to be producing current to either your first capacitor stage or into a choke if you've got a choke filter unit. But it's going to basically be putting a bigger load than nothing in it, but not a full load on the amplifier. And again, check your voltages. I forgot a little bit of safety for people that are not familiar with amplifiers. Get an alligator clip or a lead with 2 alligator clips. Clip one to your chassis or your ground, whatever it is, and so you've got one lead attached to that alligator clip. So you only have one hot lead in your hand. You're never sticking two hands in your amplifier at once.
Yep.
It's a good habit to get into of keeping one hand in your pocket when you're working on amplifiers. When I've been shocked, it's usually because I've got a soldering iron on something. I'll hit a hot capacitor or something, and it will go through my arm into the chassis. It's not going across my heart. The bad is if you have like holding both sides in your hands and electricity goes across your heart. All of it sucks, but yes. So back to
so he's talking about, so if you have a different kind, I don't know which camera's picking up what. So if you have your leads, most come with a clip, that you can plug onto your multimeter. But if you don't have that, you can just use just an alligator clip like this, and connect it to the chassis. So that's all.
Okay. Back to your seat. Sweet. So next step, turn the amp off. Preamp tubes. Put your preamp tubes in, do the same thing. Preamp tubes don't draw as much current as power tubes do. So it's, again, ramping up the amplifier in stages. Turn the amp back on. Give it 20 or 30 seconds so everything heats up. Check your voltages. So at this point, you're going to check most amplifiers, the way that they're built. The very first preamp stage is the end of the line from the power transformer all the way down across for your filaments and your B+. Very rarely is that the beginning stages. So you check it on that very first preamp tube. So, and if you're not sure what V1 is, it's almost always the one that is closest to, V1 is valve 1, which is your first preamp tube. It's usually the one closest to your input jack. And at that point, you're going to check around the globe on that tube. 12AX7, you're going to have pin 1 should have high voltage on it. Pin 2 should have, is your input. It shouldn't have very much as a grid. Pin 3 is your cathode. Should have, between 0.5 and 3 volts, say, of DC. Sorry, we're checking DC on this around the tube. We already know the filaments work, so you're checking it on pins 1 and 6 should be high voltage. 3 and 8 should be a couple of volts. If you've got that, great. Go to the next tube, and you should check your voltages. And this, you might want to look at a schematic, depending on what it is. Your phase inverter will have slightly different voltages than a preamp stage. Your reverb will have a slightly different voltage arrangement of what it is. If it's a cathode follower, it's got a different voltages of stuff. But you're just going to check those smaller tubes and see what you got for voltages. If you can, it's a great idea to write them down. For a troubleshooting standpoint, if somebody calls me up and says, I've built this amplifier, it's not working, one of the first things I'm going to do is start asking them what voltages are. If you tell me you have 0 volts on pin 1, that means you have no B+. So you follow the B+ line back and you can try and figure out where it is. So from a troubleshooting standpoint, it's real quick and easy. Write down what you got. Make a little chart if you want to. You can do it on a computer, you can do it on your phone, whatever it is. But keep track of where it is. If everything's great, awesome. You've just wasted 20 seconds of your life to make sure that everything was fine. Usually in the beginning, things won't be right. There will be something wrong that you have to figure out. Assuming everything is right, the next step of doing all this is turn it off, put your power tubes in.
And just to summarize what you said, I was writing while you were talking, but typically your plate voltages, almost universally, your plate voltages are going to be your high voltages. Your grid voltages will usually be 0, and your cathode voltages will be real low, like 1.5 to like 4 volts, with the exception of your phase inverter tube, which will have low voltage around like 50 to 90 on the grids, and cathodes will be somewhere like 30 or something like that. Right. Your plate voltages should always be the highest, somewhere between like 150 and even up to 400, like on reverb tubes.
Right. Yes.
Turn it off. All right, turn it off. Install power tubes.
Install power tubes. Make sure all your controls are set to 0.
Control set to 0. Yep.
Turn the amp back on. So this is where you might have to act fast. Depending on how an amplifier is biased. If it's cathode biased, you're probably okay. Actually, let me take that one step back before you. There's an assumption that I've made that probably should have been done in the beginning. So we have to add something at the top there. If
Sure.
you have an adjustable bias, set it right around the middle before you plug anything in. Set the pot right around the middle. It doesn't have to be specific, but around the middle. You don't want it all the way to one side or the other. The reason for that is that when you plug this in with the power tubes on, if you've got it set all the way too high or all the way too low, if it's too high, you could potentially red plate your tubes very quickly. And that's what I'm saying, why you might have to act fast.
Yep.
But we're going to do 2 stages of turning on with the power tubes here. So the first one's going to be turn the amp on, wait 30 seconds, turn the amp back off. This is going to put the amp under the most amount of stress. It's going to be drawing the most amount of current. I'm not worried about bias, but the amount of time it's taking to bias the amplifier and do anything there, the tube's not going to get into that where it would be red plating or causing damage. It's really just going to give you a moment to show you if there's any catastrophic failure quickly.
Sense.
So the next stage after that is you need to be checking your bias for stuff. Because you're going to, we want to make sure that the tubes are operating in a range. Your bias basically sets it so that the tube is functioning at the proper voltage, for lack of a better word. It's in an operating area where you want it to be making sound. It doesn't specifically have to be fine-tuned yet, but we want it to be functional. There's certain amplifiers that there's formulas that you can do for what your voltage is, for what your wattage is. There's tons of them that are online. But for the sake of this, if we're talking about, let's say we're trying to hit a current draw per tube of like 25 milliamps. Give or take 5 milliamps is fine. So what I suggest people do, again, if you're not familiar with sticking your hands into an amplifier, you can set up alligator clips onto things in advance and have leads coming out so that you can just have the leads attached and you're not touching anything. You can get bias testers that make them that are sockets that put them in there that you put the tube in that will give you a meter that's a digital readout. You basically need some way of being able to check your bias with whatever tools you happen to have available. I grew up using a meter, so I've been using a Fluke 87. It's just what I use all the time for testing my stuff with. Quick safety warning. Before you clip any leads onto anything with high voltage on it, do you ever go over like a bleeding resistor for power supplies?
Yeah, we have previous episodes that cover bleeding the caps, and also we have videos of how to bias an amp, all the different methods of biasing amps too.
Great. Then I'm going to skip all of that stuff. Basically, the next one you're going to do is you're going to check your bias, turn it on and check your bias. And you need to be quick on this because if your bias is, if you're getting 110 milliamps of current, your tubes are going to red plate. It's going to be, pretty gnarly. They get very hot. You can, you don't want to destroy your tubes. So check your bias real quick, get into the right rough area. And then we're going to, what I do is I will then raise the volume and the tone controls up or whatever it is. Fender circuits with some of them that were treble middle bass, you have to have all of them up at least a little bit or you get no sound. So you need to have all your tone controls up a little bit, turn it up, see if you hear any hiss out of an amplifier. Hiss, hum, you should get a tiny bit of noise. Then plug your guitar in and then play whatever you want to play. Something I've learned over the years, and it has annoyed every single employee I've ever had. I play the same guitar into the same cabinet, and I play the same riff every single time I test an amplifier out. Because I know exactly what that should sound like.
I have a quick funny story. My buddy, who is a professional musician, he always, to test everything out, all of his gear, he always plays the same riff, just like you said, just because he knows what that riff is supposed to sound like. He knows how to dial in his pedals or his amps or whatever to get that sound for that thing. And he's recently got divorced, and his wife used to always complain because of that riff that he always played just drove her nuts. So as soon as he got divorced, he made his first song was using that riff.
That's good. I have a couple things. I play the King of the Hill theme song because it's great single notes. I play a couple of power chords. I play a couple of full chords just to give me a quick sonic picture of what my amplifier is doing. Then, if everything works, put it in its cabinet. At that point, everything is functioning and you're good to go. And at any stage in any of these things, if something goes wrong, you stop, you fix whatever, you find what's wrong, you fix what's wrong, and you start over the checklist from the beginning.
Cool. I think that was a pretty good exhaustive list.
There's one last thing. Once it's in its cabinet and it's done, then play it. Play it for half an hour. Or let it run if you want to plug an MP3 player or something in to put signal through it so that it's actually functioning. Most failures of tubes will happen within the first 24 hours. Most of them happen even faster than that if you have a tube failure. But that will put the amp under a stress and let it actually be playable and played. And you should have no worries after that at that point. We have a different burning in process that I do for my amplifiers.
Yeah, I was going to ask you, how do you burn in your amplifiers?
So we do a couple of things. One is we put it on a load in a bench. I basically have a back hallway with a bench on it that we can actually load amplifiers onto with speaker loads, and just run them in there and let an audio signal go through them. And they're basically I let them go overnight, or while I'm here at the shop. Give them a good 8 to 12 hours to burn everything in. There's a small amount of truth to the tubes will slightly sound different as they're used. There's a little bit of a very beginning burning off when they're first fired up at the factory. That takes care of most of it, but sometimes there's a little bit more that will burn off as you're playing it in the beginning. It will find, we don't have that many tube failures, but there's been the quality of the tubes that we've been getting since the Ukrainian war in particular have diminished a little bit. We're getting, I think, a lot more tubes that might have been rejected by people in the past purely because we were having a supply chain issue. The supply chains are a lot better now than they were, 2 years ago or whenever the war started. But I was still trying to be careful about tube quality of stuff. We got to make sure that the tubes get burned in and get heated up and abused a little bit before they go out to consumers.
How many infant failures do you have with? So when a component, for everybody, for a component that fails prematurely is called infant failure. So how many infant failures do you have with like anything other than tubes? The tubes, I know tubes can be kind of all over the place, but per year, like how many capacitors do you have that fail or transformers that you have fail during that process?
I've never had, since we've been using Mercury's, I've never had one of their transformers fail in a test of an amplifier before it went out. Not a single one. Component failures, trying to think. I think last year I might have had, I think I had 2 electrolytics out of the box that were no good. I tend to use F&Ts for everything because they're consistent. This is kind of a personal preference of stuff. Some of the parts that you're going to get, it's not worth cheaping out on. I don't particularly like Nichicons. I don't like Illinois caps. I will use them if I absolutely have to, but those are the ones that tend to fail more than, say, an F&T or a Mallory or a Sprague. That is not an absolute. There is no brand of anything that is going to be component-wise perfect. it happens. We're talking about, when I buy a bunch of Mallory 150s or whatever, they're usually great, consistent capacitors to the point where I don't usually have to check them. But anything that's a component failure, I will find out because either the amp won't sound right or something's going to blow up right away. The fuse is going to pop, something's going to happen, so I will find out what's wrong with it. As far as resistors go, I don't think I had a single resistor fail last year out of the box. There was always a reason for why it failed. It wasn't because the resistor was bad, was poorly made. We tend to use carbon comps in all of our signal. And there's a reason for that. I use, wire wound cement for all the power supplies. There's different reasons for different types of capacitor resistors. Most of the times that people blow up resistors is because it's either using the wrong wattage. You can't use a 1/4 watt in a power supply. It's going to just go up in smoke. Or there's a failure somewhere. You'll see screen grid resistors go if a power tube arcs the socket, stuff like that.
What do you use for, you were talking about capacitors. What do you use for your radio? What brand for radials?
Depends on the amp as to which capacitor I'm using for what purpose. I tend to use Mallory 150s in most of my stuff. And then I'll use Sprague's if I need to, orange drops in other.
What about for your filter supply, like your electrolytics?
F&T's almost for everything. For the can caps, JJ's are fine. Most of the can caps are about the same. I haven't noticed a huge difference in, we've got tests where we test all the parts out to make sure that, if I'm going to switch brands of something and we're going to go to some new brand of anything that's a power supply, I have capacitor testers that I can test things on and see how they're going to compare and they're going to work. Almost all of the can capacitors work almost exactly the same.
Uh-huh.
So it's, JJ's.
Yeah,
they're fine. If F&Ts are cheaper, I'll buy the F&Ts. I've never found anybody that could tell me the difference in one of those in an amplifier that was built. In my old shop, we used to do a lot of A/B testing where we would try and have blind testing. So we'd have somebody facing away from the amplifier so they couldn't tell which amplifier was which. So we could actually do, two brand testing, component testing, transformer testing, speaker testing. And we just changed one part of an amplifier build. So that was it. And then you go back and forth and A/B them and you could tell which one you liked better. Not specifically that it was a better quality, but usually it's just a sound difference. There's a lot of different transformer companies. For instance, I really like Mercury's because I like how they sound. I like the quality of them. I like how they work with me. When we started off, we used Haybowers. Haybowers were also great transformers. We did A/B sonic tests between the output transformers that we were using at the time. The first output transformers we were using was just an 18-watt Marshall style output transformer. That's what we could get, 2 EL84s, and so these were almost identical transformers. To go back and forth and go, all right, which one do we like better? This. Most people don't have that luxury. But that's what we would do with filter capacitors, and we could never once find anybody that could tell the difference between the filter capacitors.
Yeah. So we had a couple questions in the chat. It was one person just asked, what was the app that I use for the resistor thing? And I don't even know what it's called. I'm going to bring it up and I'll tell you. But if you just type in resistor, does this even have a name?
You type in Google, if you Google or DuckDuckGo or whatever it is you use, resistor color code chart, there's actually printouts you can do. There's conversions. There's calculators online.
Yeah, the app that I use, it's just called Resistor. And you get a little resistor, you can change the color code, and it tells you what it is.
I don't know if I've got it. That color code also works on tropical fish caps, bumblebee caps. Bumblebees were the old Gibson ones that are in the 50s Les Paul stuff. Those all use the same color code.
There's somebody else in the chat dropping advice too, so you guys can look at that. And what was the other? Oh, about the isolation transformer. He asked what that isolation transformer was. But we already kind of answered that. It's not a giant surge protector. It just the coils.
No.
Basically, the coils are separated so that you're not attached to the wall anymore. So if you touch something of high voltage, you won't get electrocuted.
It also has an extra fuse stage in it. Yeah. The dangerous stuff about electricity is that 120 sticks you. Which what that means is that if you get hit with 240, it flies you back. Like the dryer voltage or whatever it is. 120 will stick you to a chassis and you can't let go. This is where you see, occasionally you'll see a guitarist with their arm on their strings and they'll grab a microphone stand. It can happen the same way. There's a lot of different ways of causing getting stuck to things. An isolation transformer makes sure that you won't get stuck, that there's a fuse to save your life, and it keeps you away from the main giant fuse box on the outside of your building. Because the outside of your has, the studio I'm in, we have really good power filtering. We've got a lot of power supply here. So the lines that we've got, the rails are mostly 40 or 60 amp fuses. So if I get stuck on to the wall of that's kill you kind of amperage.
Right. All right. Well, we're like at the hour mark. I could talk to Adam all day, and some days I do talk to him all day. But does anybody have any questions?
We just had a last one. I'd missed part of it because I got my phone here. But yeah, carbon comps, something.
Adam mentioned that he's using carbon comp for signal path. Do you feel there's any validity to the composition of resistors impacting tone? I've heard metal film have a hard, sterile tone.
Yes, I do. So there's an argument. There's arguments that will go back and forth with people about what type of components to use. Everything matters in a small way. I've done tests with this. I can show you this. We have done A/B tests. There is a definite sonic difference between types of components, whether it's capacitors, resistors, anything that the signal is actually flowing through. The best way to do this, if you can, is to build two amplifiers and build one with all carbon comps and one with all, whatever else you want to compare it with. Capacitors are the ones that you hear a lot more people talking about, but resistors are absolutely part of that thing. Most amplifiers, the signal's going through a lot more capacitors than resistors. So if it's a signal, on your input jack, standard Fender input jack, you've got a 1 meg that goes to ground, that's a ground reference, and you've got two 68Ks that come together for your high and your low inputs. Those, you got signal going through. It's going directly into your first preamp stage. I like carbon comps there. It is a really, really small difference, but it is a difference. It's something you can actually set up if you're building a deluxe or something like that. If you want, if you got 4 inputs or 2 inputs, you can set up 1 input for each one so you can go back and forth with them. And everything else in the amplifier down the line is perfectly the same. When you're talking about cathode resistors don't have signal on them. So it doesn't really matter that much. Because of what we do, I tend to use carbon comps for my cathode resistors for my preamp stages, just because they're right here and it's easier than going over there to my other set of resistors. I have a whole set of thing over here of all my parts right on my bench so I can grab out exactly what I need. I have a whole second section over here to the right that I've got even more stuff. And then I've got a hallway down there over there that's almost like a surplus electronics store where I've got parts and bins and I can go find stuff.
And that's on the topic of that's also on the topic of building new amplifiers. If we're talking about repairing vintage amplifiers, I encourage everybody to use, more or less use what they originally used, with the exception of if whatever they use is completely unreliable.
Absolutely.
And then if you want to make something, I've seen plenty of amps. I'm sure Adam's seen plenty of amps that someone's taken an old basement and replaced all the carbon comp resistors with metal film. And it's just like awful thing to do.
Then you get consumers that are like, well, why doesn't my amp sound like that? When you go, well, because you took everything out that is part of that. when I talk about anything a musical instrument, it's sometimes it's easier to talk about guitars than it is about amplifiers, but it's the same thing. Everything in a guitar matters, from the headstock, the tuners, the nut, the fretboard, the frets, the bridge, the pickups, the components inside, the pots you're using, the caps you're using, the jack even sometimes that you're using, the wood in all of it, what kind of truss rod you're using. All of these make small, some of them make bigger, but all of them make a difference as to what the guitar sounds like. An amplifier is the same way. Um, to be, all the way from chassis, layout is obvious, but all the small parts, even the wire you're using. When we started redoing the white amplifiers, so Fender made an amplifier called the white amplifier. There's a whole other aside. He did it for Forrest White. He did it from 1950, late 54 to about 1962. It's kind of like a variation on a Tweed Princeton. So we decided years ago to remake this, went back and re-engineered a bunch of stuff. I had a dozen of these at the time. We, had Mercury hand unwind transformers for us. But one of the things that was a hard thing to find at the time was we couldn't find really good cloth covered wire like Fender used to use. There's a guy named Steve Sost. He's an Orange County legend of vintage guitarness and amplifierness. He's a phenomenal guy. Me and a buddy were sitting on the couch trying to figure this out, called Sost up. And he was like, "Oh, you mean like the old Gavitt wire stuff?" It was like, Gavitt wire stuff? Huh. Type in Gavitt Wire Company, and it came up on Google. Called the guy up. I said, "Hey, listen, this is what we're doing." He's like, "Oh, yeah, I'm the grandson of the guy that was making that wire. We still have all of the original wire making machines. What color do you want?" And we went, "Holy shit. Sorry. Holy crap. I need this, 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 and this." And we got, at the time, all the original cloth wire. And now it's pretty available that a lot of other people are reselling the stuff. You can find the Gavitt wire almost everywhere. There's also Chinese wire that's made that's also cloth covered wire. The Chinese wire is crap, not just because it's Chinese, but because you bend it twice and it breaks, and it's also inconsistent in its thickness. The Gavitt wire stuff is phenomenal because it's absolutely consistent and it's extremely well made. Wire, because of what you're doing with transferring voltage and current through it, you want it to be consistent throughout its length of what you want. You want to make sure that you've got wire that's thick enough to handle more than what you're throwing at it. So in that sense, even the wire matters. Sorry about my rant.
No, that's good. It's all getting in the weeds. It's what we like. I didn't know that story about the Gavitt wire, but I have it. That's what I use. I think I'm going to get into the Tefls. How do you say that? ZEL. It's like real high. It's like Teflon, but it's a different different name brand. But it's super. It's what Sour Sound uses in his transformers.
Brian's a great guy. I don't know if you've had him on. He's great. Oh, sorry.
I need to get him on. Yeah.
He's really smart. Really knows.
Please feel free to curse at will. This is a safe space for disgusting language.
Fuck yeah! Woohoo! I try to be. I don't know who the audience is, so I try. I use the word fuck all the time. I can't help it. I've spoken in front of high schools with 2,500 kids and said it on accident. I try to, not knowing my audience. I try to be a little better, but it doesn't always work. But thank you. I appreciate being in a safe space. So the Teflon coated wire, there's a couple of different types of it. It has a great purpose for things. The reason that I like the Gavitt stuff in a lot of things, especially for new builders, you don't have to strip it.
Yeah.
So for people who don't know, it's called pushback wire. I don't know how well anybody can see this, but you can cut it to length, and then all you have to do is push it back a little bit, and you don't have to strip any of it. You don't have to use wire strippers. Teflon wire. I've got 3 different wire strippers on my bench for if I have to use Teflon, because there's different ones that like different stuff or different types of wire. I've got an auto stripper. Actually,
use Gavitt in all of your standard builds. Use Gavitt.
Yep, I love it.
Yeah.
Yep. Power supply, I don't, but signal stuff, yeah.
Yeah.
The stuff that's low current, lower in the grand scheme of things, lower voltage stuff, I use it for all that stuff. It's just really easy and fast to use. And for my guys that I've had working for me that didn't understand the stuff, it's a lot easier for them to build stuff with.
Alexis asks if you use shielded wire.
Yes. So shielded wire, there's certain parts of the amplifier that are more susceptible to noise than others. So the earlier in the amplification process that you get noise, the more it's going to get amplified throughout the amp. So if I pick up noise on my very first input stage going into the first tube or going into the second stage or even sometimes the third stage, all of those are shielded in everything I do. Just because it's the shielding is a mesh wire usually outside. So you got a signal, a coating, and then a mesh wire on the outside of it. I also warn people to check this with their stuff. If you don't have good brand new shielded cable and you're using something that you're harvesting off of somebody else's old headphones, old RCA cables, because sometimes people don't have a lot of shielded cable, so they'll just harvest it and use whatever they've got. Check your capacitance. Capacitor is basically two pieces of metal with a shield in between them creates a capacitor. Every amount of shielded cable is technically adding a small amount of capacitance to your signal chain. So you need to be aware of that. So if you have long runs of shielded cable, check the capacitance on the cable before you put it in, just to make sure that you're not accidentally adding an extra cap to your amp. It's one of the first things for people that are custom building stuff. If I look and see they've got a giant thing of shielded cable because they're new and they've got really long leads and everything, it's you look at this, go, all right, well, you've got a cap there, and then you're basically shunting some of your high frequency to ground with that.
And you don't have to shield every single signal wire. They're typically only depending on what kind of amplifier you build, there's only one or two spots in the amp that have really high ability to take in interference. So if your amp is so noisy that every single wire has an issue, then there's something else going on.
Right. Well, once you've got your amp built, if you've got a lot of noise issues, you can take that little wooden stick and start moving your wires around while it's on and see if your noises change or disappear, and that will help localize where your problem is. You got to remember that Leo Fender didn't start using shielded wire for quite a while. That's some of the greatest tweed amps that Fender ever made don't have shielded wire in them.
The best shielded wire that I have found, without exhausting lists from wire supply companies, is the Rickenbacker shielded wire from Mojo Tone. It has I think it's a 20 gauge inner core, and the outer in the coax is really simple to separate. And the sleeve is it's heavy duty, but it's also thin. So some of that shielded wire, all the cores are 24 gauge, and they're really fragile. I hate it. And then the wires are big, and they don't. The Rickenbacker cable from Mojo Tone, and it's not any more expensive than anything else. So I love it. That's what I use.
Yeah, it's really good stuff. Gavitt also makes really good stuff. There's a bunch of suppliers that make decent stuff. It's hard for ordering wire directly from Gavitt is hard for people that aren't businesses, because Gavitt wants you to order at least 1,000 feet as a minimum.
StewMac sells Gavitt wire, and it is the cheapest that I found on the internet. And they also sell 20 gauge, where New Sensor sells it by the thousand, or they sell it, but I think they only sell 22 gauge. So I get all my stuff from StewMac at $35 for 50 feet or something.
Right. Yeah. I mean, you can even, people told me you can buy it on Amazon. There's I don't know if it's StewMac that's selling it through Amazon, but somebody is selling Gavitt wire.
I think it's StewMac through Amazon. I always wait for StewMac to have a 20% off sale, and then I order $1,000 worth of wire.
Right. That's it. I've got a couple friends that work over there, so they're always lovely people. I love the guys at StewMac.
Someone asked, how do we push back the wire without fraying it? The trick there is to not push it back with your pliers, just pull it back. So I have it, if you can see it on my, let me see if I can get it on my screen here.
While you're getting your screen out there, Gavitt wire shouldn't fray. It's waxed.
Well, it frays, you wipe the wax off when you push it with your, so like,
when you push it, it should just slide right back. The stuff that comes apart and frays, usually that when you do that, usually isn't Gavitt wire.
All right, let's see. It's right here. So here, let me snip it off. So when you have it snipped, you just grab and push it through. That come through. There you go. And then if you need to pull it back further than that, then just grab the then you grab the actual conductor and just pull the wire. But if you take it and you push it like this, it'll start to fray.
You should never have to pull that much back on a piece of wire, though.
Yeah. You just pull a little bit. Yep.
Yeah. It's very easy to overdo it with stuff. I think in any of the builds that I do, the most I ever have to pull off is 3/8 of an inch to pull back. You shouldn't even need to usually do more than about 1/8 of an inch. You don't need a lot. Because you're not jumping big gaps with the wire. If you're using it for filament wire and you're jumping pin 4 and 5, you need about 3/8 of an inch. That's about it.
Yeah, I was going to say that too. Alexis, bad wire cutters. If your wire cutters aren't sharp, it won't make a nice cut.
I find that a lot of people, a lot of builders, I've got 3 different sets of wire cutters and 3 different sets of wire strippers on my bench right now that I use all the time, depending on what I'm doing.
All right.
Wire cutter just because you never know what size you're going to need or what purpose you're doing. And don't ever cut strings with them, please.
Yeah, Kirk, that cloth wire with the inner wire, that stuff sucks. The only kind of cloth wire that's worth anything is the Gavitt brand cloth pushback wire. That's anything else is that I've ever used is terrible.
It is. And if you're ever doing restoration work on old Fender instruments, old Fender guitar amplifiers, any of that stuff, it is exactly the same. It's not a replica. It's those same machines. It's as close as to exactly the same thing that Leo Fender was using in 1948.
Yep. All right. Anybody got anything else for us? Adam, you got any last words of wisdom?
No, not at all. I'm just
Dude, that was awesome.
Thank you. I had a lot of fun.